Hi all, we are back with another amazing educational episode with us channel. So today we are going to learn about Karnaugh maps and how to solve boolean algebra using them. So as usual, let's begin. So Karnaugh maps are complicated compared to normal solving of boolean algebra. But however, once you learn this, it's very easier than boolean algebra because all you need to do is draw a table and calculate it properly, and then you directly get the solution of the boolean algebra in a more simplified manner. So let's move. So what is a Karnaugh map? So the Karnaugh map, which is also called as a K-map, is a method of simplifying Boolean algebra expressions introduced by Maurice Karnaugh in 1953. So as I said, it is a more easier method of simplifying Boolean algebra expressions through a table, a tabular format, rather than solving it in a normal method. So you need to use various kind of laws such as the De Morgan's law and whatnot, but in Karnaugh map you don't need to use any of them. All you need to do is to make a table, calculate the answer directly. So the Karnaugh map reduces the need for extensive calculations, just like I said, and the time taken to simplify Boolean algebra through the standard method using various laws is reduced. So Karnaugh maps are used to simplify real-world logic requirements, so they can be implemented using a minimum number of physical logic gates. So when you solve it using a Boolean algebra, it takes a certain amount of physical logic gates, and that amount could be reduced if you use a Karnaugh map because it directly gives you the simplified format from the one you need to solve, and you can directly find the easiest way to make the logic gates to be connected. So moving on. So this is actually what a Karnaugh map looks like. So this is how you solve the Karnaugh map. So you need to draw this down, and then you need to circle them in a way that it comes by either by 1, 1, 1, 4, or it comes as 2 here. So same as the circling can cross from one edge to another. So if one starts from here, you can finish it from here. So as you can see, the yellow box, it takes 1 and 1 from here and 1, 1 from here. And this red box is also another square, and it has taken 4 ones in the same position rather than crossing from one edge to another. And also it can be taken by 2 as well, so it comes as 2, 4 likewise. As I said, same digits can be circled but only in groups of 2 or 4. So this is rather a big Karnaugh map usually that comes with 4 Boolean digits, as here A, B and C, D are used. So if it's 3 digits, it will be like only 4, and this side 2, and it will be like 8. But here we have 16 squares because there are 4 digits from the Boolean algebra. So however, we can't, digits cannot be circled in a diagonal basis, so you can't just diagonally circle them. Okay, let's move on. So we are going to learn step-by-step basis on how to extract a Karnaugh map. So before we actually draw a Karnaugh map, we should first take the question, which is a Boolean algebra function, and then we need to make a truth table and take the outcomes of the truth table. Then we take those answers into extracting our Karnaugh map. So we are taking this example, which is a plus b dot c. It will be our Boolean function. So I am going to take this possible answer of this Boolean algebra function as x. So I have written a here, then b, c and x. So I'm going to put the respective values that comes for these three tables, A, B and C, respective values for A, B and C. Then we are going to extract X. So A plus B is 0, plus 0 is 0, and 0 multiplied by 0 is 0. This comes as 0. And then this also comes the same because 0 plus 0 equals 0 into 1. Anything multiplied by 0 is actually 0. So this comes as 0. Even this, because there is 0 here, it will be also 0. However, here in the fourth one, 0 plus 1 equals 1, and 1 into 1, here since there is no 0, the multiplication will actually come off. So the answer will be as 1 here, because 1 into 1 is of course 1. And then here, however, C is 0, so we can assume that at any instance C is 0 because C is a multiplication value here. So anything multiplied by 0 is 0, so all of these come as 0, so this will be 0, this will be 0, this will be 0, and this will also be 0. So however, here in the sixth one, so 1 into 1 plus 0 is 1, and 1 into 1 is 1, so this will be 1. And this one also, because all three are 1, this will of course going to be 1. So we are going to take these answers into our Karnaugh map in order to get the solution in a more quick manner. So we are going to put them into Karnaugh map now. So give me 1 minute. So if you go to the next slide, I have already created the Karnaugh map necessary for this. So since there are only 3 boolean values, we need only an 8-block Karnaugh map, which I have used here. So let me show how to write down the necessary values here without further. So we are going to take these 3 values in order to extract the Karnaugh map. So you need an 8-block Karnaugh map. You can write it down here. One, 2, and 3. Then I'm going to put A and B in this side and B over here. Sorry. A on this side, B also on this side, and C on this side. So this should be so we are going to put this as 0, 0, 0, 1, 1, 1, 1, 0, and this side 0 and 1, because here 0, 0 means A value is 0 and B value is 0, and here represent the C value, so C value is 0 and 1. So in this case, on how to extract the truth table into a Karnaugh map, so we are going to take the values of A, B and C. So here A value is 0, B value is 0, and C value is 0, which means it is this row we are going to take here. So the answer representing X is 0. So we put 0 here. We go for the next one. This A value is 0, B value is 0, but C value is 1. So which will be this row, second one. So in this one, still the answer is 0. We're going to put 0 here. The next one is A value is 0, B value is 1, but C value is 0. So which will be effectively the third row, but still the answer is 0. We can take third row, put 0 here. The next one, where is A value is 0, B value is 1, and C value is also 1, which is the fourth row. And the answer here is 1. So we are going to put 1 here. And the next one, A value is 1, B value is 1, but C value is 0, which is, so when you write a Karnaugh map, we don't write it as 0, 1, and then 1, 0 and 1, 1, but rather you put the 1, 1 before 1, 0. So in this case, when A value is 1, and B value is 1, and C value is 0, we effectively take not the fifth one, but the seventh one, seventh row. So here the answer is 0, So this will be 0. And then in the next one, which is A value is 1, B value is 1, and also C value is also 1, which will be the 8th row, where every value here is 1. So the answer is definitely 1. So we are going to put 1 here. And in the next one, which is A value is 1, B value is 0, and C value is 0, which will be this 5th row. And answer is 0. We are going to put 0 here. And the last one, which is A value is 1, B value is 0, and C value is 1, which will be the last one left here, which is the 6th row. Answer is 1, put 1 here. So that's how we actually got the answer, which is actually at the slide after this one. So we're going to move there. So see, we got the same answers as I show in the Karnaugh map. And we will use the output of the truth table to fill the Karnaugh map as said in the presentation. So now next job for us is to circle these ones as necessary in order to extract the complete answer. So we are going to circle the answers of the logic Karnaugh map. So we are going to take this as a SOP Karnaugh map. So in case of an SOP Karnaugh map, we are going to circle the number of ones in the blocks. So there are 3 ones, which is here, here, and here. So we are going to circle them. So we can only circle 2 by 2 blocks because there are not enough ones in order to circle in a 4 by 4 one. So we can't circle 3 at all at once. So we're going to circle these 2 as the first 2 and the other ones here. So you can overlap them actually. And then when extracting the answer, we only take the numbers in the above of the table, which are actually constant and does not change. So we are going to the first circle. So in the horizontal perspective of that circle, when you take the values of A and B, so you can see actually the value of A actually changes from 0 to 1, but the value of B does not change. So we are only going to extract B here, B out of these horizontal side. So B is 1. So if B is 0, we are going to take the complement of B. But here the number is 1, which has been constant in the side of B. So we are going to take B as it is. And from this side, of course, C does not change because there is only C here. Yeah. So all 3 numbers C remains as 1. So we are going to say C as it is. So the first answer will be A, B. Sorry, A, C. So there are no complements. And in the next one, which is again we are going to take the next circle. 1 will overlap. So here it will overlap. So here, however, the value of A remains as 1. However, the value of B changes. So we are not going to take B in the second circle. We are only going to extract A. And since A's number is 1, which is being constant, we are not going to take the complement of A, but we are going to take A as it is. And C is also C as it is because it is 1 for all 3 numbers. So the next one will be A and C. I'm sorry, this should be actually, this shouldn't be A and C, this should be A, B and C. And this should be A and C. So since the sum of products is in the answer, we are going to put a plus mark here. So this will be the answer for the Karnaugh map. So we don't need to go a lot of way in order to solve this. We have actually acquired the answer here. And we can use this as a logic gate. So when you take this as a logic gate, B and C will come as an AND gate, and A and C will also come as an AND gate, and it will connect with an OR gate to give the final output, which is X. So that's how you actually create the Karnaugh map and extract the answer in a SOP Karnaugh map. So we are going to learn now. Next, we are going to learn the 2 types of Karnaugh maps, which is SOP and POS. So let's move on to our next slide. So as I said, the two types of Karnaugh maps we use is the sum of products, which we currently made a sum of the sum of products, and the next one is the product of sums, and we are going to learn that too today. So when it comes basically to both of those types of K-maps, we are going to use the same method in order to extract the Karnaugh map, and there's only one slight difference when it comes to differentiating the POS form and the SOP form extraction of answers. So in the SOP form, as you already know, we take the Karnaugh map. However, we are only going to circle the ones in this Karnaugh map. So here we have taken one and another one over here. So we aren't going to actually circle it like this, because both of these ones are being circled at least once, so this will be disregarded. So we are going to go and take these two as it says, and we are going to take the answer directly. So that's how the SOP form works. And moving on to the next one. This is the POS form. So the difference in a POS form is you circle only the zeros, as you can see, and we are going to disregard the ones, and we are going to extract the answer from here into here by only taking the zeros. So in the same way, the only difference is we are going to circle the zeros instead of ones. So that's basically it about Karnaugh maps, what you need to know. So actually this is much easier than using boolean algebra. So I'm going to I'm going to put the link in the description if you need this PDF actually, so you can understand more about Karnaugh maps. So thank you for watching, and now make sure to like and subscribe so you can stay for more videos like this, and let me know in the comment section down below about what you think about our educational videos, and if you need any preferences, we are always ready to change our way of teaching to actually make it more feasible and interesting for you. So I hope you learned something today. So I'll see you in the next educational video. This is Ask channel, and thank you for watching.